Good evening, students. Let us start with the paper discussion. So first, I hope I am audible, right? Yeah. Okay. So let us first start with the first section A questions that we have. So please keep your papers handy with you and please keep a notebook or something to write the answers. If anything doubt, you can please ask towards the end of the paper discussion. First, let me discuss all the answers. Then at the end, if you have any doubt, you can please ask. So first, we have section A, 15 marks, that is MCQ based question. Which of the following changes involves in a frictional force? So answer is A, kinetic energy to heat energy. So in case of a frictional force, suppose when object is in a motion. Now, if you just take an example of rubbing of a palm, when you rub your palm, so your hands are set into motion, your palms are set into motion, because of which, so whenever there is a thing which is in motion, we have studied that whenever there is a state of motion, the energy is kinetic energy. And when you rub your palm, that energy is getting transformed into heat energy. Your palm becomes little hot, so kinetic energy gets converted to heat energy. So in case of frictional force, option A is the answer. Second, how much electrical energy is consumed by a 100-watt lamp? So this has been given to you, that power is given to you for 12 hours. This is the time given to you in the month of June. So duration is given. Please remember, June means 30 days. The time limit for June means 30 days. So you will have to consider that. So in the month of June means you will have to consider for how many days it will be there. So you need to find electrical energy. Electrical energy consumed by a 100-watt lamp used for 12 hours every day in the month of June. So you will have to just convert this, multiply all the figures. That is electrical energy. We know that electrical energy is power into time. So that will be 100 multiplied by 12 hours each day in the month of June. So that will be 30 days. So that will be 100 into 12 into 30. So when you just multiply this, you get the answer will be 3 6. 12 threes are 36 and 3 zeros. 36,000. So, but see the unit. If you see the unit very carefully, so your unit is very much required, which is required over here. Power unit is watt, and in hours you have kept. So this is watt hour. And if you see the unit, we have 36 kilowatt hour as the answer, option D. That is 36. Kilo means 1000. So 36 kilowatt hour is the answer. That is option D. In which of the following activities is work not done? So you have to make sure that the work is not done. The answer will be C option. The Radha is carrying load on her head. So since she is simply carrying load on her head, so there is no work done. It is the work is done. It is at rest. So in other all the other cases, there is a motion. So work is been done. In option A, B, and D, there is a work done because there is a motion which takes place. Class 2 levers are designed to have mechanical advantage greater than 1. C option. MA of a single movable pulley. This is a fixed question, that is 2. MA of a single movable pulley is 2. Next question, distinguish between single fixed pulley and a single movable pulley. So you need to write 2 or 3 points which are given in your text also. Distinguish between single fixed pulley and a single movable pulley. State examples of all three levers of a class of levers found in a human body. So examples of all three class for class 1, class 2, and class 3. So if you follow the text which is given to you, in case of class 1 levers, it will be nodding of a head. In case of class 2, it will be the weight on the toes, weight of the body on the toes. That will be an example of a class 2. And for class 3, you can take forearm. If there is some load in your arm, so the forearm can act as a class 3 lever. So just examples are mentioned, 3 examples in each case, 1 example in each. Draw a diagram of a block and a tackle system having velocity ratio of 5. VR is 5 and mark the tension in each strand. So you just need to draw the velocity, the block and tackle system. Again, this diagram is there in our textbook. You can refer text. For 5 velocity ratio 5, there will be 5 pulleys which will be drawn. So that 5 pulley we have to draw and just show the tension and effort load wherever it is there, that we have to show. Derive an expression for kinetic energy of a body having mass m and a momentum p. Here the desired expression which you need to show is kinetic energy equal to p square upon 2m. This expression is required to be derived. Again, it is readily available in our text and we have studied in class also. So kinetic energy will be p square upon 2m. This expression is required. Actually, kinetic energy we can also derive it as half mv square, but that is not asked, because if you see the question, kinetic energy in terms of mass and momentum. So if you see this formula here, it has momentum and mass both. So this is p square upon 2m. And a truck weighing 1000 kgf. So I can say from here that mass is given 1000 kg, changes its speed from 36 kilometer per hour to 72 kilometer per hour. So here you are expected to convert the kilometer per hour to meter per second. So let us assume initial velocity u is given as 36 kilometer per hour multiplied by 5 by 18. You convert kilometer per hour to meter per second, multiply by 5 by 18. So this will be 2 times. So this is 10 meter per second. Final velocity is 72 kilometer per hour. Again, you convert that. So this is 1, this is 4. 4 5 this will be 20 meter per second. And for 5 minutes, the time given here is t is given as 5 minutes. So 5 minutes means in seconds if you convert. So that will be 300 seconds. So I repeat once again, you have been given mass, you have been given initial velocity 36 kilometer per hour. 36 kilometer per hour needs to be converted in meter per second. Then you have been given 72 kilometer per hour, even that needs to be converted in meter per second. And time is given in 5 minutes, that need to be converted in seconds. Calculate the work done. The work done, we have work energy theorem, half m v square minus u square. Now, why did I take this formula? Because if you see the given data which I have been known with mass, velocity, v, and u. These three quantities I know. So I'll use that relation to find the work done. If you know the work energy theorem has this half m v square minus u square. These three variables are only there in case of that formula: mass, velocity, and initial velocity. So first you need to find the work done by the engine and its power. So first let us find the work done. So that will be half into 1000. I can write 10,000. V square, velocity square. Velocity is 20. So 20 square, that will be 400, minus u square. U is 10. So that will be 100. So W will be equal to, you can just strike off this 500. 500 into 400 minus 100 is 300. So work done will be 15 into 10 raised to 4 joules. 15 into 10 raised to 4 joules. That will be the work done. And you need to find power. So we have known that power is work done upon time. So 15 into 10 raised to 4 divided by time is 300. So that will give you 500 as the answer. 500 is the answer. 500 watt. Units are very, very important. If units are incorrect, you may lose your marks there. So power is work. I repeat again, once again, the numerical. A truck is weighing 1000 kg. Speed is given. Initial velocity, final velocity is given. 36 kilometer per hour. You need to convert to meter per second. 72 kilometer per hour is final velocity converted to meter per second. In 5 minutes, time is given as 5 minutes converted to second. And find the work done. So the work done is using work energy theorem, half m v square minus u square. And on solving that, you get 15 into 10 raised to 4 joule work done. So power is work done upon time. So just divided by time, you get the power value. Section B, you need to answer first question as k plus u is constant. You need to derive this. So this is a derivation again, which is there in our text. You might have understood this. K plus u is constant that we need to derive. Next numerical, we have B. A pulley system with a velocity ratio 4 is used to lift a load of 150 kgf through a vertical height of 20 meters. The effort required is 50 kgf in downward direction. Then you are supposed to find the distance moved by the effort, work done by the effort, and mechanical advantage. For your reference, you can refer textbook also. This is a solved example from the textbook. This is a solved example from the textbook. If I'm not wrong, this is in 3B. Solved example from 3B. Example number 3 from the textbook. So although the numerical is big in the textbook, we have just taken here two things to be founded: work done by the effort and mechanical advantage. Calculate the distance moved by the effort. First, you need to find the distance which is moved by the effort, work done by the effort, and the mechanical advantage. So three things are supposed to be found. So first, you see velocity ratio is given as 4. Load is given as 150 kgf through a vertical height of distance is given as 20 meters. So we know that velocity ratio is distance moved by effort by the distance moved by the load, dE upon dl. Distance of effort to the distance by load. So from here you can find the distance of effort, because the question is asking calculate the distance moved by the effort. So distance moved by the effort will be velocity ratio multiplied by distance moved by the load. Velocity ratio is given as 4. Distance moved by the load, here it is mentioned, that is 20 meters. So 4 into 20. So distance moved by effort will be 80 meters. This is your first point that is to be solved. So first data, using the initial data, we have found out the distance moved by the effort will be velocity ratio times distance moved by the load, and that is 4 into 20, that is 80. Second thing they are asking is work done by the effort. So we know that work done is force into displacement. So work done by the effort will be force due to effort, or we can say directly effort multiplied by displacement due to effort. Right? Work done by effort will be effort into displacement by effort. So how much effort has been there? So that is 50 kgf. Here it is given. The effort required is 50 kgf in downward direction. You have to convert that kgf to Newton. So that will be, I will assume here 10 to round up. So I will assume effort is 500. Okay. I'm converting kgf to Newton. You multiply by 10. We actually multiply by 9.8, but for our easy calculation, we are assuming 10. That will be 500 multiplied by displacement by the effort. Yeah, that we have found out, that is 80. So this will be 40 into 10 raised to 3 joule. Again, units are important. So this will be 40 into 10 raised to 3 joule. Third thing they're asking is what is the mechanical advantage? You need to find the mechanical advantage. Mechanical advantage is load upon effort. Load is given as 150. Load is given as 150, and effort is being known as 50. So if you divide that 150 by 50, that will be 3. That is load and effort, right? So that is the mechanical advantage. Just a second. Just a second. Just give me 2 minutes. Just 1 second. If there is any doubt up till now, then you can please ask. Give me 1 second. Yeah. So next one, question 3A. A pump is used to lift a load of 500 kg of water from a depth of 80 meter in 10 seconds. Calculate the work done by the pump. Power power rating of the pump if its efficiency is given to us as 40%. Okay. So I'll take the next slide here. So the given data says we have been given a 500 kg of water. So if you see, there has been mass given to us, 500 kg of water. This is mass given to us, depth that is height, time that is 10 seconds. Calculate the work done by the pump. So we know that we can find the value of work done, and we need to find the power. We need to find the power rating. Three things are supposed to be found out. So when I have mass, height, we know that work done can be found out using MGH formula. So an MGH means M is given to us 500. G you can take it as 10. G you can take it as 10. Since it is not mentioned, you can take it as 10. H is given as 80. So when you solve this, 3 zeros. So 40, 4 zeros. 40 into 10 raised to 4. You can add 40 into 10 raised to 4 joule. That is the work done. And power we need to find. So power, we know that power is work done upon time. So work done, we have found out 40 into 10 raised to 4 divided by time was given as 10 seconds. So just divided by 10. You get 4 into 10 raised to 4 watt as the power. And power rating. To find the power rating, you should know that power rating is power divided by efficiency. Efficiency. Efficiency they have given as 40%. So power they have given to us, that is uh, 4 into 10 raised to 4. We have got power as power upon efficiency. Power is 4 into 10 raised to 4. Efficiency is given as 40%. 40% I can write it as 4 into 10 raised to 4 divided by 0.4. So when you solve this, you get 100 kilowatt as the power rating will be 100 kilowatt. So this thing you need to remember, that power rating is power divided by the efficiency. Whenever there is efficiency given to us in the question, so that will be power rating will be power divided by efficiency. Next, we have express 5 kilowatt hour in joule and then in calories. There are two things. You need to first express it in kilowatt hour. So it is given in joule. So we know that 1 joule is 3.6 into 1 kilowatt hour. We can express it 3.6 into 10 raised to 6. So you just need to convert. So multiply 5 kilowatt hour, you will get it in joule. For calorie, please remember that 1 joule is 0.24 calorie. 1 joule is 0.24 calorie. So just use that unit 0.24 for your multiplication. So just multiply with that value, you will get that answer in calories. First, you convert it in joule. After converting in joule, you convert it to calories. That will be easy. Draw a diagram of examples in each class of lever. So any one example you can take of your own choice for drawing the diagram. In each class of lever, for class 1, class 2, class 3, each class you need to draw one diagram. State and explain the examples in each of the following case, that is maximum work done and zero work done. So work done will be maximum when theta will be 0. Work done will be 0 when theta will be 90, right? Maximum work done, theta should be 0. We know that W equal to Fs cos theta. So when theta is 0, cos 0 will be 1, the work done will be maximum. In this case, you can take the example, an object which is coming down because of acceleration due to gravity. Suppose an object coming down from a height because of acceleration due to gravity. In that case, the force is the gravitational force in downward direction. Displacement is also in the downward direction, so angle is 0. You should not write that if you are throwing an object up. If you throw an object up, the displacement will be in upwards direction, gravitational force will be downward, that will be 180 degree. So that is wrong. That is not the correct thing. For maximum work done, force and displacement should be in the same direction. So same direction it will be only when the object is coming down. So when it comes down, then the force and displacement are in the same direction. Zero work done will be when theta is 90. Theta is 90 is a case of a circular motion. In case of circular motion, because of centripetal acceleration or centripetal force, so the displacement becomes 0 in that case, and work done is also 0. Next, question 5. A lever of length 9 centimeter. So lever length is given 9 centimeter. Has a load arm which is given to you 5 centimeter long, and effort arm is 9 centimeter long. To which class does this lever belong? It is very simple to understand. If you see, the lever length is equal to the effort arm. So this is an example of a class 2 lever. In case of a class 2 lever, the effort arm is greater than load arm. So you can just simply see the relation between load arm and effort arm. So effort arm is greater than load arm in case of a class 2 lever. So effort arm is 9, load arm is 5. So this is an example of a class 2 lever. Draw a diagram of the lever showing the position of the fulcrum, directions of load and effort. So you need to draw one diagram. So suppose if this is the lever, here is the effort, here somewhere I'll take the load, and here is the fulcrum. So this should be 5 centimeter, this should be total 9 centimeter. So this is the diagram. This is the required diagram. So this is an example of a class 2 lever where the fulcrum is at one end and the lever arm is equal to the effort arm, that is 9 centimeter, that is given to you. What is the mechanical advantage and velocity ratio if its efficiency is 100%? So we know that mechanical advantage is a load arm divided by effort arm. I'll take first velocity ratio. Both things we require to find out. Velocity ratio, I can take displacement of effort upon the displacement of load. Achha, since the efficiency, okay, you can do in other ways also. Since the efficiency said in the question is 100%, the first case, what is the mechanical advantage and velocity ratio of its efficiency is 100%. Efficiency 100% means they both will be same. Why? Because if you see efficiency, the formula is ma upon velocity ratio. 100% means the efficiency you can consider it as 1. So in that case, it will be ma will be equal to vr. Both values will be same. When efficiency is 100%, we consider it as an ideal case, ideal machine case. In case of an ideal machine, efficiency will be considered 1, and 100 upon 100, that will be 1. So mechanical advantage will be equal to velocity ratio, that will be equal to 9 by 5. 9 by 5, the arms are given to you, 9 centimeter and 5 centimeter. So 9 by 5, it is 1.8. If I'm not wrong, this is 1.8. So mechanical advantage is also 1.8. Velocity ratio is also 1.8. Both will be equal because efficiency is 100%. And next, when the efficiency is reduced by 50%, or when the efficiency becomes 50%, then only mechanical advantage will change. So initially the mechanical advantage was 1.8. Now the mechanical advantage will reduce to 50%. Now the mechanical advantage will be 0.9, half of initial. When it was 100%, we got mechanical advantage as 1.8. Now since this 100 has reduced to 50, the mechanical advantage will also reduce. We know that velocity ratio does not change. Velocity ratio remains the same. That is, it will remain the same. That is 1.8. Okay. So velocity ratio will be 1.8. Mechanical advantage 0.9. When it is 100%, both are same. That is 1.8. And lastly, you need to derive an expression for mechanical advantage, velocity ratio, and efficiency, where symbols have the usual meaning. So you need to just derive efficiency is mechanical advantage of upon velocity ratio. So the derivation will have 2 marks for it. So I guess this was the last question. So if any specific doubts to anyone, they can ask. Yes, yes, you can please ask your doubt. Chitman can ask.
Sir, can you explain a question for second one?
I am unable to hear you, Chitman. Are you saying something?
Sir, hello, sir.
Can you again? I cannot hear. I guess. Can others hear what he is saying? Or you can just write in chat. That is fine. Any other doubt to anyone you can mention in your chat? Question 4.2. Okay. Question 4.2 is state and explain examples in each of the following case: maximum work done and zero work done. So again, I will repeat: maximum work done means theta will be 0. W is equal to Fs cos theta. So when theta is 0, so W will be just equal to Fs. So that is the maximum work done example. In that case, we will take an example of an object which is coming down under the acceleration due to gravity. So in that case, the force is gravitational force. Displacement is downward displacement. The object is coming down. So force and displacement are in the same direction. So since they are in same direction, the theta is 0 in that case. Maximum work done with theta 0 and 0 work done. 0 work done means your answer should be 0. So when the work done will be 0 when theta is 90. So in case of theta 90, circular motion can be taken as an example because of the acceleration, centripetal acceleration or centripetal force. Circular motion may the work done is 0. Okay. So in case of 0 work done, the example will be circular motion, theta equal to 90 degree, and in maximum work done, theta will be 0. An object which is coming down under the force of gravity, that can be taken as an example. Anything else? If not, then we can conclude with the meeting. Okay, I guess no other doubts. So let us conclude for today. Thank you.